So here we've got a plane, and when it passes the radar station, which is right here, it's 1 kilometer above the radar station, and then it climbs at an angle of 120 degrees. So if we want to measure how fast is this distance changing between the plane and the radar station. So I'm going to make a bigger diagram of this actually. There we go. We've got this is 120 degrees. We've got this is 1. We know this is changing, and we know this is changing. And unfortunately, we can't use Pythagoras because it's not a right-angled triangle, and we can't use trigonometry. We can't use SOHCAHTOA, but we can use trig. We're going to use the cosine law, and the cosine law is a squared equals b squared plus c squared minus 2bc cos a. So for this example, it's going to be y squared equals 1 squared plus x squared minus 2 times 1 times x times the cosine of 120 degrees. So simplifying, I've got y squared equals 1 plus x squared minus 2x times the cos of 120, which is negative a half. So I've got y squared equals 1 plus x squared plus x. So that's a little bit simpler to take the derivative of, which is what we're going to have to do because we know that this distance is changing at a rate of 300 kilometers per hour. That's the speed of the plane. And we want to find out what is dy by dt at a specific time. And when, just taking a look here, when after 1 minute. So there's a little bit of unit issue there, but we know we're going to have to take the derivative. So let's do that first. And dy by dt equals derivative of 1 is 0, so it's 2x dx by dt plus dx by dt. And I know I need to find the dy, what am I asked for? Yeah, sorry, I'm asked for dy by dt. I just had to do a double take there. So I'm asked for dy by dt, which I'm going to isolate by dividing everything by 2y. But before I do that, I need to also figure out what x and y are. So in the specific instant that we're talking about, 1 minute has elapsed. How far has the plane gone in 1 minute? So 300 kilometers an hour times the time he's taken. And we've got to keep the units the same. So 1 minute is 1/60th of an hour. So that means that it's 300 over 6, which is 5. He's gone 5 kilometers. So x is 5 kilometers at the instant we're looking at. And how do we get y then? Well, we use this equation here to find y. So y squared will be 1 plus 5 squared plus 5. So that means y is the square root of 1 plus 25 plus 5. So that's the square root of 31. So at the instant that we're talking about, x is 5 and y is the square root of 31 kilometers. Now we have all the bits that we need. We have y, we have x, we have dx by dt, and we just plug our values in and isolate for y. So let me do that in a new page. So I've got 2y dy by dt equals 2x dx by dt plus dx by dt. So I've got 2 times square root of 31, dy by dt we don't know, equals 2 times 5. Dx by dt was 300 plus another 300, and if you now isolate dy by dt, you will get 1650 divided by the square root of 2 times root 31, which works out to be about 296 kilometers.